Hello learners, I'm Dr. Poonam Agarwal. In this video, I'll be discussing about rapid Lubering shunt, which is the shunt seen in RBC for the sake of production of 2,3-BPG, that is 2,3-bisphosphoglycerate. 2,3-bisphosphoglycerate. We'll see how this shunt of glycolysis takes place in RBC, which we spell it as rapid Lubering shunt. For this, as I have discussed in part 1 of the glycolysis, the steps of glycolysis should be known to you. This I have discussed in part 1 of the glycolysis, where I have told you how by various steps the glucose is converted to pyruvate or lactate. Of course, in RBC it is the lactate because it's anaerobic glycolysis. Now, I will be just focusing on this portion of, for detail on glycolysis, you can see the part 1 of my YouTube channel. Subscribe YouTube channel and you can see part 1 of glycolysis there. And after that, you learn this rapid Lubering shunt. In this rapid Lubering shunt, I'll be now just focusing on this aspect of glycolysis. Where 1,3-bisphosphoglycerate is seen to be converting to 3-phosphoglycerate. In RL shunt, suppose if I have to discuss the RL shunt, I have to focus only on this portion of the glycolysis in RBC. We have one enzyme in RBC which is converting 1,3-bisphosphoglycerate to 2,3-PPG or 2,3-bisphosphoglycerate. And this in turn is converted to 3-phosphoglycerate. The enzyme which is needed to convert 1,3-bisphosphoglycerate to 2,3-bisphosphoglycerate is known as bisphosphoglycerate. Bisphosphoglycerate mutase. And the enzyme which is converting 2,3-bisphosphoglycerate to 3-phosphoglycerate is called phosphatase, which is removing inorganic phosphate from second position and producing you 3-phosphoglycerate. This mutase enzyme is just shifting the first phosphate of 1,3-PPG to second position to give you 2,3-bisphosphoglycerate. And then phosphatase enzyme is acting on this 2,3-bisphosphoglycerate to make you 3-phosphoglycerate. So in RBC, not for all glucose molecule, only for certain glucose molecule, the intermediate 1,3-BPG is having this kind of shunting. As you understand that if the shunting is taking place for 1,3-BPG, you do not have this PG kinase step getting encountered. So this point of ATP production is not encountered when this RL shunt is occurring. This is called RL shunt, where this mutase and phosphatase enzymes are acting and we tend to get this 2,3-bisphosphoglycerate. This is called RL shunt. So during RL shunt, RBC is having loss in terms of ATP production, because this was the point, if you see the part 1 of the glycolysis, this was the point which was producing 2 ATP, because this step was occurring twice in glycolysis. So there is a loss of 2 ATP when this RL shunt is taking place. And so for sake of production of this 2,3-PPG, RBC is bearing the loss of ATP. 2 ATP is less produced. Once this 3-phosphoglycerate is further utilized in the pathway of glycolysis, the pyruvate kinase step very well is producing ATP. So in RBC, only 2 ATP is being produced by substrate level phosphorylation at pyruvate kinase step. And as you understand, the glycolysis has utilized 2 ATP at the starting itself. So 2 ATP is produced and 2 ATP is utilized. That results in no gain of ATP, 0 ATP. When the RL shunt is taking place for the glucose in RBC get to have this 2,3-bisphosphoglycerate, but the net production of ATP becomes 0 because 2 ATP is utilized initially at glucokinase and PFK1 step, and 2 ATP only is getting produced at pyruvate kinase step. The step PG kinase is not able to produce ATP because this step is not encountered at all in RL shunt. I repeat once again, not all the glucose molecule is taking this kind of shunt. Majority of the glucose molecule is going in routine anaerobic glycolysis in RBC and thus producing you 4 substrate level phosphorylation ATP, where 2 is utilized, resulting in net gain of 2 ATP. But for those glucose which is taking RL shunt and thus producing 2,3-bisphosphoglycerate, those glucose are not resulting in any net ATP production, because that case you have only 2 ATP at pyruvate kinase step and 2 ATP because it's utilized, the net gain becomes 0. So this is about the RL shunt, which is seen in RBC, mature RBC, for the sake of production of 2,3-PPG. You can ask one question here: what is the importance of 2,3-bisphosphoglycerate? Why it is produced in the RBC at the cost of ATP? The answer is, it is a very important biomolecule which is going to unload oxygen from hemoglobin in the RBC. Unloading the oxygen from hemoglobin in the RBC, it's a result, it is causing the deoxygenation of hemoglobin. So once the RBC is unloading the oxygen, this is RBC, it is unloading the oxygen, this oxygen will be then available to peripheral tissues. Until the hemoglobin of RBC is unloading the oxygen, that oxygen will not be available to tissues. So it is very important that it is unloading the oxygen from its hemoglobin association, and that's being done by 2,3-bisphosphoglycerate. This 2,3-bisphosphoglycerate binds in between the beta globin chain and in the hydrophobic pocket and results in unloading of oxygen from the heme of the hemoglobin. This is said to be negative allosteric modifier of hemoglobin oxygenation, right? So this is the importance of 2,3-bisphosphoglycerate, and at high altitudes where easy unloading of oxygen is required, more of the glucose is being shunted in RL shunt for production of more of the 2,3-bisphosphoglycerate, which can unload the oxygen easily. For more such videos, you can subscribe my channel, Dr. Poonam Agarwal, and press the bell icon so that you get the notification of new videos. Thank you very much.